It is my pleasure to introduce you to Mr. Howard Massey. Everybody in here knows him. And I call him Brother Howard. We're all brothers. And but I used to enjoy thoroughly going out to his shop and just wasting his time. Because he would sit and just tell me all kind of stuff, and it was a joy. So I'm gonna give you this. I don't need that. Yeah, you're on TV, man.
I've never used a microphone.
Yeah, but you're on TV. Yeah, you're on TV.
Don't broadcast that. Dan sort of wanted me to do a little bit of a talk on I think the HF antennas, something with the balance in it.
Want me to stack you off?
Huh?
Want me to stack you off? I'll stack you off with a question.
All right, go ahead.
Counterpoise or no counterpoise?
Well, that depends on what kind of antenna you're going to have. Most quarter wave antennas require counterpoise. The half wave infed does not. What I was going to say is, how many of you got the 49-to-1 balun? You wind it yourself?
No. With your help.
Yeah. Okay. Well, you know what I'd like to do would work. What I'd like to do would work better at a QRP or something, and we can save this part of it for that. I would like to do that, and if anybody wants to build one thing good about the infed half wave is that I've got one until my daughter ran over it with a lawnmower, and I had almost a dead perfect match from 40 meters to 10 meters.
Right.
And what happens is, with one length of wire, as you move up higher in frequency, the resonance goes higher in frequency. So with one piece of wire, mine was 66 feet, which is a half wave at 40 meters. So that's about where I stayed most of the time.
Right.
And so I enjoyed doing that.
Worked pretty good at 10.
Yeah. Well, it would be slightly high, but most of the new radios today have tuners built into them.
3-to-1 tuner.
And it'll just take it right down flat, no matter where you go.
You have to go to the
No, so what I did is, my neighbor had a couple of pods of fishing poles, and they were up about 50 feet. And I asked her one day, could I have one? And she said, cut all you want. So I cut one down, and I cut all the stuff off of it, and I tie wrapped it to the fence to keep it straight for a while, so it dried out a little bit. And then I you did a couple of math problems on it, which was nothing. And it come out to about 67 feet at the speed of light. So you're going to have to trim it anyway. So I trimmed it down, and what you've got to watch with my rig expert that I use, maybe some people don't realize this, but SWR don't mean crap. It does. But these things here will tell you so much more.
Yeah.
And the data, let's see if I can get something up here on this thing.
It'll tell you if you got a fault in your cable and
Yeah.
stuff like that.
But what I was going to say is that when you're taking the SWR measurement, then you can punch your data on here, and it will continue to show you the data if you want it to. And the thing to really watch is the resistance, especially when you're winding the core, because if you get too much transformation when you're winding it, like too many turns on the secondary, the low end will be about 40 ohms or maybe, but it'll never get to 50. And so you take some of the turns off the back, and then you can keep checking it, and you'll get to the spot where it'll. Mine that I made. Well, Dan had one. I won't say I made it. Dan. Yeah, we made it one day, and we got it to about 50 or 51 ohms. Okay. And that's where you want it. But the little trick that I use, and you can see some other people using it, is that get you a little cheap roll of wire, and my little push-up. This is just the end where the wire goes on. Okay. You know, right here, and these are just a screw-on connector here. And this is ground, but I rarely use it. But what I do is I put a little spool of wire right there, maybe with 100 foot or 150 foot, number 28 or something like that. And I put this up at one end, and I stretch the wire out slowly with my analyzer hooked to here. Hello, my analyzer hooked to there, and I set the thing up to tune the ham band 30 megahertz up to that frequency, and I start walking backwards slowly. If you don't hook that to it, you'll start reading every quarter wavelength. So this will actually peak out pretty close to a half wavelength on all the bands you've got the length of wire for. So when I got up to about 40 meters, about 66 feet, that thing went almost dead flat. And but you can move forward or back, or if you need to wind some back up on the spool, you can until you get it right. It's something you want to learn from and not just rush through it and take what you get the first time. Just keep playing with it, and you'll find that I actually have another one that I used. I used a little smaller core, and by the way, if you take a measurement of just what's sitting there, it'll read about 5 to 1 with nothing on it. And I was going to show you that this, I imagine, how many said they wound their own core? Wound their own transformer? I even bought a resistor to read the output. This is so simple. I used a smaller core. I don't know. I don't have ARRL stuff anymore. I bought a 5,000 ohm resistor, put it on the load, and you can get that dead flat with that, and also find out where the resistance is on the. Is
that a variable resistor? No?
It sure is. 5K.
5K. That's going to ask for more.
But anyway, it's better to use the long wire. Would anybody, when we have a QRP, like to bring their own stuff? We'll help you wind the cores.
Yeah. And
check them out.
I would love that.
And if you don't know how to wind it, we'll do it. It's a lot of fun. Yep. And anybody want to talk about their antenna a little bit?
Well, I'm building a long wire right now, 71 feet, using a 9 to 1, which is three pieces of wire wound around the core.
450 ohm.
Right. And that's what I'm building now. That's what I've been experimenting with. And I've got enough room up in the back, believe it or not, to get 71 feet of wire. I don't know if it's not going to go straight.
Will your neighbor let you use their screen door? Oh, yeah.
It will work. Doesn't matter
copper wire or shielded wire? Or,
No, you.
okay, copper.
Just single strand. I'll give you this is the kind of throwaway wire you use to find. What you do is put your little rope through the center of this and take the wire here and tag it onto there and just pull it backwards. I hook my meter right up to the box here. Hook my meter right there, and I just slowly start. I put that this wire up as high as I can put it on something that's not too out of reach, and I clean the end off and put it on there, and just slowly start walking backwards. And if you want to do it prematurely, you can go on there and put a piece of red tape or something where you probably wind up. That way you won't have 100 feet to wind back on the reel. But you can use this to get what you want. Then you can use a better piece of wire, and it's a little less expensive that way. That you know, I bought some wire, like
Steel coated?
yeah, it's that steel coated copper from the Hamfest in Orlando last year, and I paid 40 cents a foot for it. This year they wanted $1 a foot, unless you bought over 100 foot. Then they would sell it to you for 80 cents. I said, you might as well keep that, and I'm not going to pay you. You can buy coax cheaper than that. But that's what I was going to talk about tonight, and just prime us up for a QRP whenever they work it in, and
What if you don't have room for 6 feet? What if you just you're
well,
$35
there is some ways you can do it. You know, when you wind a wire into a little bit of a coil, it creates more and more lower frequencies and less length. And I was going to show you. Is there any way to write on this board?
I reckon. I don't know.
One behind you.
One over here. Open the panels.
I was going to show you how to do it more or less with. Hey, look.
You got everything in there you need.
Okay.
Pretty sure it's dry right. Dry right.
Yeah.
You don't want to sharpen the greens here out of your way.
Huh?
Need this greens here out of your way.
Nah, I think you'll be all right. Hello. I think everything's like me. I'm dried up.
Could be. Ages before they've been using it, so.
You know, if you take a coil of wire and if you put a capacitor across it, you have a resonant circuit. And if you ground this in, that's pretty much low impedance. And this point right here, you know, we built a little UHF antenna, or showed you how I did.
Mm-hmm.
This is low impedance and that's high impedance. And the antenna, the output of that transformer was 2450, 2,450 ohms. And you can stick that right here, half wavelength, in-fed half wavelength, and you can make this variable. That way you can change the frequency. You can make this variable. Now this is without a core. And you can tap this. And you can almost tune that. And you can, if you want, put a capacitor here and vary it. And you can almost tune any, if you got enough wire on here, and a big enough capacitor, you can almost tune any of the VHF bands, and generally it'll be a single frequency. It won't be harmonics where you set it, but you can reset it. And that makes a good situation. This happens to be low impedance here, and this will be high right here.
Would they be a fairly high Q circuit?
Would this be a high Q?
Yeah.
These two would.
That's what I was thinking.
And when you tap this down here, that's lower frequency, lower impedance, same frequency.
I was thinking that second half would be very high Q.
Yeah, this is high Q. That's actually what you want. High Q, higher frequency, yeah. The only thing you have to watch out for, if you're going to run a kilowatt, you got to have big wire, right? And the plates on this capacitor has to be quite wide, otherwise they'll melt.
A good size. It'll arc across the cap.
Huh?
The voltages are high enough to cross the arc.
Yeah, well, that's the high point of this, by the way, is excuse me, well, we'll call this current. If that's the current pattern off of that antenna, it'll be high voltage on the half wave. So and you can do it many other ways. You can do this same thing, and you can tap this core wherever you want to get the impedance you want, and then you can tap it up higher for your high impedance, and you tap it down low for low impedance. And you can almost do it with 2 or 3 parts without that core. And this is the way a tuning box works anyway. Just like the L network, you know, you can have if your antenna is here, you can put this here or tap it down wherever you need it for your high impedance, and tap it down here for low impedance.
These tuner boxes we have, you push the button on the radio to tune the antenna.
Yeah,
How long does it take the tuner to adjust itself?
depends on how well it's made, I guess, but it doesn't take long.
A couple of seconds.
Yeah, and you know, most of them won't tune over 3 or 4 to 1 anyway. But anything you build inside the box has got to be substantial for the power you're going to run. And if you build VHF, UHF stuff, you have to use silver wire, because all those frequencies run on the skin. It's called skin effect, and you want copper on the HF stuff.
That was, you know, some guy's tuner one time, and it was clicking and making noises for quite a while. Yeah.
Yeah.
I was wondering. Non-resident. I did put counterpoise on it.
You know, on one like that, they're stacking the cores to get extra power out of them. Some of them using, I've seen as many as 4 on there, and I think one that probably handle the lower power stuff, maybe 200 or 300 watts without a lot. But if you mount this stuff right on that edge of that plastic, first thing you might see is a brown spot coming through the other side when you crank it up. My little 100 water won't do that.
Most amateur transceivers are set to tune a 3-to-1 SWR.
Yeah.
It's very rare to find a transceiver that can do more than that. Tintec had one. The Tintec, Stone Molders went out of business. Yeah. They had a tuner in there that could go higher than 3-to-1.
Anybody got a simple question?
Just something I was thinking about, don't all antenna, which really they're a trans batch, is really what they are. It's not an antenna, is a transmitter batcher. Do they not have a certain amount of loss in them?
Yeah, they do. Yeah.
And
And I was going to say, this core right here has got about 2 dB loss.
Because Dave Birnbaum, K2LYV, and one of our tech specialists wrote an article in QEX magazine.
Yeah.
Back a few years ago, calculating losses and antenna.
You
Good article.
know, most of the television stuff that I really grew up with,
Right.
the splitters and things like that. When you split it twice, you got almost 4 dB loss. Depends on the frequency, and that's because of the little bit of wire loss, and the core is about as big as your finger. And you know what? Those can be made so easily. If you're familiar with a 2 dB splitter for TVs, probably everybody's got one. I'm going to show you a really simple way. If you take a piece of wire like that, and then you take and split it like that, or wind it together, split it and wind it together, and then the binocular or the balun, you run this wire through here and this wire through here, and you make this to a connector in here, and this is the input. You've got a 2 dB splitter with about and I would use silver wire if you're going to use it for VHF, and most of them don't. But that is as basic as you can make it. Just a little monocular core.
Howard, if you're running a end-fed long wire like Dan's making, can you, I'm talking about running it down the top of the rail of a fence, a long fence, and I probably would have to make a 90-degree turn where the fence, it's not like.
Are you running the radiator along the fence? What are you running along the fence?
With just the long wire, that's 90 feet or whatever Dan's talking about. 90 feet's a long ways to go without bending it. Can you put a 90-degree bend in?
You want it horizontal to the earth?
Yeah, horizontal to the earth.
Probably wouldn't be a good idea. I think if you play with it and get it in the right spot, it'll work. But you don't want it down close to the earth.
It would be about eye level.
That's about where it cuts your head off.
Yeah.
With 1,000 volts. Don't forget, there's a lot of voltage on that thing, even at 100 watts.
Okay.
I'm talking about safety.
Yeah. That's what I'm asking.
And also, you want to keep that hot end away from where that radio is close to, because you'll have some feedback and burn. And with that wire laying along the fence, your coax is going to be real close to it. It's going to couple right into it.
Okay.
And it'll be right on the whatever you put it on.
So don't do it perpendicular.
Yeah. So there's a lot of safety involved in that. Yeah.
I recommend getting an antenna analyzer like you have, Howard, and I have. It saves you a lot of headaches. If you're building antennas, it saves you a lot of headaches. Even the cheap DNA will work.
Yeah. Oh, yeah.
Get more stuff out of the DNA if you see it.
That is well, that pays for itself time and time again.
How do you turn this off?
Don't
Thrill
worry
it.
about it. What else is radio?
When my kids at school get older.
You quit working real quick. You got the right order on that.
Yeah. That'll turn it off.
We put a rotary phone in front of a 10-year-old. I doubt seriously it would be able to figure it out. Rotary phone. I don't think I've ever seen one.
You know, this thing came with Varta batteries, rechargeable. They're the best batteries I have ever seen.
They're good size.
Yeah.
And damn lithium batteries, but every once in a while, 10 power. Yeah, don't get them wet.
Questions, anybody that I can answer?
I have a question about the GHF, UHF question.
V-
You've got the mathematical formula and you,
You already have it.
the higher the frequency, the lower the antenna height and quarter wave.
The lower you might can have it.
But why when I put it on my DNA, it looks like an EKG? It goes up and down from one end of the frequency to the other.
Well, each one of those is where it's partially resonant.
That's correct.
Yeah. It's like this in-fed halfway we built. Mine was tuned almost perfect all the way up, almost to 60 megahertz. From 7 to about 60. And when you get up to 60, the core starts losing efficiency. That's why you put that little 110 or 20 picofarad cap across the input to smooth out the core. If you wound that core for as high as you could get it in frequency and forget the low, you'd only have a few turns on it instead of 14. Question? Maybe you could talk to Dan or whoever, maybe a QRP, and we could get together and build something. Somebody needs one, and we could help them put it all together. The best thing to do, most people want to go on YouTube or whatever and buy one, or Amazon and buy it, but you don't learn anything like that. We're supposed to be efficient enough to build something.
You can build your own G5RV.
Yeah, oh yeah.
Dimensions are in
Yeah.
books all over.
And antenna books. There you go. See, you don't want to use that. No, you
It's a
can.
mediocre antenna.
Yeah.
Well, Howard, we could probably schedule something in for our QRP. I don't know what anything special we're doing this month or not.
Oh, we're doing the photo.
Oda, maybe next month we can do that.
They're always looking for something.
We're doing as part of our hands-on.
You know that place in Winter Haven was pretty nice. We could maybe get that sometime. Yep. I was going to, maybe not Lake Ship, but the other one. What was that on? Lake?
Crystal Lake?
No, off of Havendale there.
Oh, like
Partridge. Yeah. Yeah. There's a lot of room there, and we can even use the parking lot.
That's right, yeah, check out.
Huh?
Check out the wire.
Yeah. I would say anybody that probably wants to build something, bring the material you need, get a core, get one from somebody.
We can give them a list of materials to bring with them.
Yeah,
Or we could use my front yard, it's about an acre and a half.
that worked.
Oh,
You don't have any gators in the front yard, do you?
Problem.
yeah.
Once you find it, there's plenty of room. You could have 3 or 4 people stretching out like that. Not hitting.
What are you walking around with RF burns all over?
That fixed it.
Oh, I live in 12 acres. My front yard is about 8 and a half.
Something else, anybody?
We think for lightning protection is HF, long wire.
You know, if somebody wanted to build something like a 3-element Yagi for UHF or VHF, there's only 3 elements that really work hard on that reflector driven element and director. But what you can do, if you got a minute, we got a minute?
Yeah, sure. I got a couple of minutes. Three-element monobander, like say for 10 meters or.
Well, yeah, mono.
Give you about 8 dB gain.
Well, it'd probably give you 7, maybe,
So
3-element.
your spacing's got to be right.
Huh?
Spacing between the elements.
Well, of course. Here's what we'll make it safety. We'll put a reflector on the back, and theoretically it should be about 2/10 of a wavelength longer than the driven element.
Longer than the driven element.
This should be, you know, they talk about velocity factor with coax, right?
Right,
Well, these have a velocity factor too.
okay.
They got to be shorter. In most books, will tell you make it 5% shorter.
Driven element.
Make this 5% shorter,
That's shorter than the element.
5% longer, and this one's 5% shorter than this one. But here's what happens when you hook a coax to that. You might find that the impedance here is not 50 ohms. It may be 70 or 60 or 40 but what you'll find in these first three elements, you can put more, of course, but what happens when they fire a signal from here to here, it's going to come back. It's going to reflect back part of the signal. And what you do is you move this element. Let's say this is 60 ohms here. When you move this element backwards, the phase changes. When you get this phase and this phase into effect, the resistance of this element goes down. It's like adding current to it, right? Mm-hmm. So if you add current, it's like lowering the resistance. Is that right?
Adjusting your elements to get
You just move the element and watch the phase or the resistance. And when you move this backwards, if it starts going down and then starts coming back up, go back to where it went to the bottom and stop. And then do this one the same way. And when you get all three of those just right, you may even have to trim this a little bit if you're real close, you know. But those are a quick way to remember how to, you're changing the spacing, which changes the phasing of the current flowing in this element right here. And, or if it's a 2 element, you can forget this. You just move this backwards a little bit to get it down, or raise it back up. And if you need to go lower in frequency, you can start whacking that off. But that's a quick way to get you something going quickly. I bought a lot of those rods from. They're actually aluminum welding rods. You can get about 36 of them for $20, and they make perfect antennas. Question? Everybody's asleep.
Dan showing a picture. He didn't build it yet.
Huh?
Dan was sending around a picture while you thought he built it yet.
Yeah. What do you do for lightning protection on long wire?
Pray.
You built it.
I've been hit by lightning. I know exactly what that happens. Yeah. Disconnect.
I seen lightning roll off of my front guy wire. Of course, the tower's a little tall, but I seen a blue ball of fire come off of that. That must have been plasma because it was hot.
It blew out a light socket and killed a receiver that was hooked up to. Blew out a light bulb. I had a technician write a letter saying in fact it was lightning. It's a horrible thing getting hit.
You know, a lot of the guys didn't really know how big a capacitor to put in here, or the value. And you can take one of the micro variables and you strap it across there and just twist it down till you get it perfect. Or you get it. Yeah. it's a mica capacitor. Yeah.
They have a little bit of variable on the back of it. Yeah.
Well, they're usually flat, a flat pack, and some of the electronic equipment has these little patterns in them that are round, and they're ceramic, and they have it's not it's not copper, it's zinc in the middle of them, and what it does is it removes the inductance instead of.
Could you use a small air variable? They have little small air variables that are like tiny.
You can, but
I
it
was
would
worried
melt.
about creatures getting into it.
Well, you use that with a meter,
Right.
and it won't melt with that, but you can find the value you need like that, and then put a permanent one in with about 1,000.
You can seal it up.
Well, you
Plates and deep in the capacitor and, well,
yeah, you need at least depends on the voltage you're going to run or power. You need at least 1,000 volts on the capacitor.
That's what I was wondering.
And those little old bitty surface mounts, they got some that long, it's 1,000 volts. Yeah.
You gotta have a microscope to look at that darn thing.
Yeah.
Quite high.
And the hands that are not shaky anymore.
I can't remember what that article Dave Birnbaum published. It was a little deep, but he showed how to calculate the losses. Yeah, he went through the math and everything. I mean, the guys, I called him the professor.
And he does what?
Dave Birnbaum, K2LYB,
But
one of our tech specialists.
Yeah.
He actually holds some patents with Xerox, and he was a college professor as well. When I had trouble with physics class in 2009,
They still make Xerox?
well, I guess he gets his retirement from them. But when I had trouble with my physics class in 2019, I went to a Tampa, Hampshire, to the Tampa clubhouse. I got problems with transformative formula. He takes a piece of scratch paper and say, "Here, try this." And I went home and spent a half hour. Don't even got that right. You didn't even think about it. So I called it.
Well, he's done this a million
Well,
times
taught physics for many years.
Yeah.
The guy is, he wrote several articles for the X magazine.
Right.
And if you can read them, they are very, very, very hot. Unfortunately, I've heard that recently, he lives in East Tampa, his health's not good now, but he did presentations at TechCon for years. An excellent presentation.
Dan, you got anything else?
Workshop on Python.
No, thank you, Howard. That's awesome.
Well,
Thank you very much.
I'll clap for you. Well, I would like to do a QRP. We've made several antennas over the years down at Kiwanis Park.
That's a good quick one.
We made 8 or 10 of those flower pot antennas.
I remember we made the tape measure beams back 10, 11 years ago.
Oh, yeah. I've seen them on the beam antennas and using a tape measure to hunt animals.
We did it up there at the Kiwanis Park up there.
Yeah. Using
Who found who
Yes, it was very handy.
who found 2 of the foxes?
Oh, yeah, that was one about 2 or 3 years ago.
That was a homemade antenna.
Yeah,
Here you go, the homemade.
yeah. They're up there near.
We found the hollow one.
Well, this is back before you were around, I think, Dan.
Johnson hit them.
He had a fox or 2. And
fox hunts are complicated.
Oh, I think I hit one.
Howard, I've got one more question, if you don't mind.
I don't.
I've got a pile, and I mean almost an endless supply of Belden 1694, which is RG6
Yeah,
for video cable.
Yeah.
75 ohm.
It's 75 ohm. And I'm wondering how useful that is to anybody. It's up in my shop up in Delaware. I'd bring a whole bunch of it down here if it was useful to somebody.
Well, you can use it on TV at 1.5 to 1 with a 50 ohm.
I used it on HF back when I was first licensed because I didn't have any money. I used RG6 television coax up to 100 watts. It worked very well. Give it a try. It was a little bit of a mismatch, but it still worked.
You remember when the cable TV was out south of my shop
Right.
on that 450-foot tower.
Uh-huh.
They took they changed out their coax down the tower, and it was solid, 75 ohm.
Oh, yeah.
And
CATV hard line.
yeah, and he came by and asked me did I want some of it. I said, yeah, I'd like to have a couple of 100 feet. And he gave me that, and it went up on my tower, and there was hardly any loss. There was a little, 1.5
Yeah.
each end, but it was.
I was gonna say about 1.5 to 1 anyway.
What kind of connector is there on that? That large cable, is it?
Well, this wasn't the what do you call it?
Use a coring tool?
Huh?
Have to use a coring tool?
Yes, you had to use a coring tool.
Oh, yeah.
We used they used all Gerald equipment.
Okay.
And I had a Gerald coring material and core. It just goes down in there and scrapes it out. And I can't even remember what. I think it was just a standard connector,
Okay.
but it was made bigger at the end where the coax goes through it. And on some of that coax, we actually had to grind the center conductor down. Yeah.
I used CATV coax for years on that.
Sure.
And it worked very well.
Sure.
I made a little bit of a mismatch.
Yeah.
1.5 to 1. Who cares?
Yeah.
If they wouldn't notice it on the other end.
You could build a little simple L network and take it out.
Yeah, you could have a little. It
Yeah.
needs back to that work if you want to be perfect.
Yeah.
But it just, I had a tube radio and it didn't care.
Something I can do sometimes. How many knows how to use the matching charts and stuff like that? We can do that. Huh? Yeah, the
Smith chart.
Smith chart. Yeah. I'll tell you what, with a Smith chart, with a Smith chart, and just a little bit of knowledge of it, you can make it match anything.
Oh, yeah.
Sim Smith makes a system that you can plug your resistance and reactance into that thing. Just plug it in, just write them in the frequency you want, and hit one part on there. It's a combination. It's a L and a C in one piece.
Right.
Yeah, and R, and you plug it in, and within about a second, you got the resolution answer, how much loss is in it, and everything else. That really works good. But the best thing to know is how to use that Smith chart good.
Yeah.
All
your engineers are referring to
towers. Capacitors and inductors have all kinds of loss in them. They're not perfect. And when you get up in the UHF regions and the gigahertz, those things start acting like resistors, reactors. You don't know where they're going to wind up. But you can use coaxial cable. It's the best you can use at those small higher frequencies for L and C. That's why you see all these traps and things made, because they're narrow, and your lumped components like L and C, they're broader.
Do you have anything else? Thank you, Mr. Howard. Yes, sir. Thank you. Fred.
Thank you.
I blew up signal today. Have a little problem with noise on HF. Here, we're on a cruise over the weekend.
Right.
Came home and I'm getting a 20 across 40, across 75, 80. And what do you guys found? I mean, I got an old portable AM radio. That's the first thing.
AM radio is the best thing to use.
I know it's not in my house, it's over power.
Right.
So everything's dead in my house and I still got it. That's it. Anybody else have any other suggestions? Solar radio.
I did some of the engineering for WIPC out here when they were in business. And it was raining one night, and Tom Thornburg called me, and he said, Howard, they were on low power at night.
Right.
And he said, one of the guys here, he was a big band guy, and he played big band music. And he said they're getting drowned out in Winter Haven with line noise. And he said, "Do you think you can find it?" Now it was pouring down rain, and I was a little bit lucky because I went up to Dundee Road and went towards Winter Haven, and I had my AM radio on. By the way, the best frequency is 135 megahertz. That's AM only. But anyway, as I was going down about halfway down that road, I seen blue arc coming off of one of the poles out there.
Power line.
I wrote that down. And that night I called Florida Power.
Yeah.
And I told them what pole it was, how to count it, where it was at,
Yeah.
and where it was arcing up there. And they sent a guy out there the next day, and their problem disappeared.
Yeah.
But the AM radio, if that's all you got, that works good.
Right.
Just find you a
Yeah,
blank
small
spot.
transistors that are in the
Just
radio,
find a blank
put it on
spot.
the station and just walk around with it.
Yep.
Yeah.
Now these real radio guys, like you were talking about, they have a dish, a parabolic dish, and it's made for reading real high intensity stuff. But man, you can find out what insulator it's on with that thing
Yeah.
if you can get them to do it.
I've had the city of Bartow come out. They do exactly that.
Yeah.
They got a guy that hunts down noise on these power lines when an amateur radio operator complains about it.
Yeah, that's right.
They know they can get themselves in trouble. Don't do anything
Nobody
about it.
complains they don't do it.
Yeah.
I went on twice. They went around my neighborhood trimming trees.
Yeah, we used to have problems with salt.
Yeah.
Intrusion on the insulators.
Yeah.
Either that or they cleared up all of that.
I watched the guy washing the power lines with an intermittent washer.
That's deionized water.
Yeah. And he was hosing the lines down.
Yeah.
But it was salt. Funniest thing I ever saw. That's down in Plantation, Florida, where I live.
You seen these guys do these high tension lines,
Yeah.
these 200,000 or 300,000 volt lines
Yeah.
with a helicopter? They
Oh, yeah.
they fasten them together with to the helicopter.
Yeah. The guy's working on the line.
They make them one
he's on it.
potential.
Gotta be at the same pitch.
Yeah.
He's on the damn thing.
They might have a static charge on
One of my wife's cousins up in Tennessee, he did that for years,
Years.
and
They
he
fixed a lot
lived.
of those. That helicopter pilot's got some nerves, though. He has to hold that thing steady.
Well, you can't do it on windy days.
On a windy day, you're in trouble. I watched that happen. I watched it. It made me afraid for everybody. The pilot, the lineman, all of them. Just one little thing goes wrong, and that's the end up for everybody.
Huh?
Yeah.
You can't. You gave this to me.
Yeah. That was.
10-4, we're out.
Yeah, walk on with that.
Thank you, Howard.
That's